Let's look at what we need to do to use the VSEPR theory. The first step is to draw a Lewis dot structure of the molecule or polyatomic ion and identify the atom whose geometry is of interest. For us, this is usually the central atom, but in complex organic molecules, we may identify the geometry around several atoms. The second step is to count what we call electron charge clouds around the atom of interest. This is simply the number of lone pairs on the atom of interest plus the number of atoms directly bonded to that atom of interest. At our level, 4 is typically the highest number of charge clouds, although there can be as many as 6 electron charge clouds around an atom. Once you know the total number of charge clouds, as well as how many of those charge clouds are lone pairs and how many are bonding electrons, you can determine the molecular geometry of the molecule or polyatomic ion. We will look at this in more detail. You need to remember that the charge clouds will orient themselves to minimize repulsion or to be as far apart from one another as possible. The geometry of a molecule depends on the number of charge clouds as well as how many outer atoms there are, or how many of those charge clouds are bonding electrons. Thus, molecules with the same number of charge clouds around the central atom can have different shapes if the number of lone pairs and outer atoms are different.